We are students from INS Torrevisens, and we present Twig Shelter, a self-sufficient refuge located at Estany de Llebreta, Aigües Tortes, at an altitude of 1,620 meters. Our objective is to create a sustainable space integrated into the landscape and designed to withstand high mountain conditions where winters are long and cold, with frequent snowfall and freeze-thaw cycles. The main challenge is building within a national park, minimizing environmental impact while ensuring durability. To achieve this, we follow strategies such as lightweight foundations at different levels, dry construction systems with rapid assembly, and a compact architectural design with a sloped roof to manage snow. Considering the construction phases, we have created a Gantt chart to estimate the project duration, resulting in a total of 72 days.
We also orient the shelter to the south to take advantage of the solar energy and daily, protect the north facade from cold winds, and extend it to allow storage from personal mobility vehicles. All of this responds to the site's harsh climatic conditions. We carried out a study using beam and GIS with the aim of determining the optimal orientation to maximize solar energy use. We analyzed the solar path over a 6-month period of the shelter's location and also conducted a slope analysis of the terrain together with the soil layers, all thanks to ArcGIS. The foundation used insulated footings tied together with connecting beams, followed by timber columns to reduce the impact of the ground, following a lightweight foundation strategy. The rear walls act as structural elements while also serving as retaining structures for the soil.
The main structure is resolved using CLT panels and a system of solid timber beams, which is efficient and highly prefabricated. Those panels are used for walls, floors, and roof, providing thermal mass and reducing the carbon footprint. The roof is made of wood covered with sheet metal, with a 45-degree slope to allow snow to be shed by gravity and integrate with the landscape. The facade is an industrialized system of the linen tape type or similar, with a lightweight timber frame insulated with rock wool. On the exterior, it incorporates a structural OSB board, a waterproof membrane, and a finish of sheet metal panel. The whole system is completed with appropriate waterproofing and drainage solutions to prevent infiltration and protect the structure from environmental moisture and rain.
The shelter is self-sufficient. We integrate photovoltaic panels on the roof with a battery storage system. For heating, we use a biomass stove, taking advantage of sustainable natural resources and reducing the CO2 footprint. This system is reinforced by the thermal mass of the CLT timber panels, which help maintain indoor temperature and reduce the level of thermal transmittance, which we have calculated and adjusted within the limits set by the CTE. We manage water by collecting rainfall and snowmelt, which is stored and later treated to make it suitable for consumption. In addition, grey water treatment and reuse systems are implemented. Finally, in terms of ventilation, a controlled system is proposed that minimizes direct air exchange with the exterior under cold conditions. Twig Shelter is a refuge designed to withstand mountain climates, reduce environmental impact, and demonstrate the potential of timber as a structural material. With prefabricated systems, energy self-sufficiency, and integration into the landscape, we believe it is a coherent, sustainable, and realistic proposal. We have also carried out an energy certification which yielded very favorable results.